Okay, so in this video we're going to look at radian measure. This is something which is extremely important and that you need to be very comfortable with going into university in first year, or you're going to be in trouble. But which nevertheless people are really scared of. People struggle with this. They find it extremely confusing, and it's just a disgrace. It's very simple. Like so many things in high school, though, teachers they find a way to make it complicated and confusing. It's completely unnecessary. It's really ridiculous. I get kind of annoyed about this actually, as you may be able to tell. But there's no reason to be confused by this at all. We are going to explain it and make it clear actually what it is and how to convert between radians and degrees, and you'll never ever be confused about this again. So the first thing we're going to do is talk about really what is radian measure, what is it, and why do we need to measure things, or why do we want to measure things in radians instead of degrees? This is something that they typically don't do in high school. They don't tell you this. They just kind of jump into it and give you some formula, and people feel really lost and have no idea what's going on. So we're going to start with the basics and work our way up from there. So what is radian measure? Well, in order to understand what radian measure is, we first need to sort of revisit what are degrees. What is a degree? Degrees are ways of measuring angle in a circle. So this is 1 degree here, as you can see. Not actually, it's just it's sort of roughly the size of a degree. It's a little sliver of this circle, and this is an amount of angle. This is an amount of the angle that we have in the circle, right? So I kind of take these 2 pink sticks, and I put them at the center of the circle, and then connect them to the edge, to the circumference, and then open them a little bit. And how much I opened them, that is 1 degree. That's an amount of the angle, the total angle that is in the circle. And if I want to think about how much of the circle, or how many degrees there are in a circle, I can think of this as, so everyone's heard that there are 360 degrees in a circle, and you can put these tick marks in, and it keeps going all over. We can think about this as breaking up, as if I unfold the circle like this. I unfold this purple line that makes the circle like that, and then I break it up into 360 equal pieces. So I put all these little tick marks in, and just pretend they're equal. They're very not equal, obviously, but they're supposed to be. So suppose I break this up into 360 evenly spaced pieces. Pieces of equal size, so the tick marks are evenly spaced. And then I wrap it back up. I wrap it around and turn it into this circle. Well, then what I have is one degree. Each of the tick marks, right? When I go to 2 successive tick marks, and I connect them to the center of the circle with lines like that, that gives me that sort of amount of rotation that you have to go from one to the other. That gives you 1 degree, as we call it, of angle in the circle. And there are of course 360 of these. So it's just a way of breaking up. 1 degree is what you get when you break up the total amount of angle all the way around the circle into 360 pieces. But what's special about 360? Why not 100? Why not 720? Why not 180? Why not 500? Why not 1,000? 360 is a number that was just like picked out of the air, basically. There's nothing special about 360. And so mathematicians want something less arbitrary. They want to have a way of measuring angle in a circle that is measured so that the angle is measured in terms of one of the intrinsic qualities of the circle, one of the intrinsic properties of the circle. And that is the radius. A circle is basically just a radius. You may not have thought about it this way before, but I take a stick, which I call the radius r, and I put it somewhere. I center it at a point, and then I spin it around in a circle. I just rotate it. I rotate it all the way around, right? I fix that point and spin it and spin it and spin it, and it comes back, and all the points that it traces out are the circle. That is what's on the circle. That's one of the ways of thinking about this. So the radius, and then a position in space, the center of the circle, defines the circle entirely. And the same circle can move around, right? This circle with whatever this fixed radius is can move around, but the radius will stay the same. So mathematicians think, all right, is there a way that we can define the angle in a circle in terms of just the radius? And there is. What we do is we take we take the radius, and we kind of cut it out like a piece of string, and paste it into the outside. Well, and it's gonna straighten, so I'll have to do kind of like wavy pasting by hand here. We paste it into the outside of the circle, and that gives you a radian of angle. If I paste a radius, however long that is, onto the outside of the circle, and then connect both points to the origin, like or to the not necessarily the origin. If it was centered at the origin, it would be, but to the center of the circle, then I get 1 radian of angle. We can also think about this. Down here in terms of this diagram, because I think this is a useful way of thinking about it as well. We can think about this as cutting the, and this is one of the keys to understanding the conversion, as taking this circle here, and let me just zoom in really quickly and delete these pink dots because they're going to be slightly annoying. There we go. Okay, sorry about that. And breaking it into pieces, which are 1 radius of distance apart. So that's going to be a radius, that's going to be a radius, that's going to be a radius. However long that is. I'm breaking it up. And then it's not going to go in evenly, right? When I did degrees, I decided I was going to break it into 360 pieces. So, of course, those pieces were all going to be equal. I was going to have exactly 360 of them. I wasn't deciding how long those pieces were going to be. Here, what I'm doing is saying, okay, I'm going to break this into pieces which are a certain length. Their length is r, the radius of the circle. So I'm not going to, and it would actually be more of them. And I don't want to be misleading about this. I wasn't counting as I was doing this. This is bad. There's going to be more of them. I'm not going to. You know what? I want to adjust it just here carefully. We're going to figure out how many there are supposed to be. But the point is that I determined the length of the piece, not how many pieces they're going to be. So if I want to convert between radians and degrees, it's going to be a little bit harder than just saying, okay, how many degrees are in 1 radian. I actually have to think about this a little bit. And again, teachers are generally just going to give you a formula and say, remember this, and nobody does because they have nothing to grab onto, right? There's nothing that it doesn't make sense. Why is it this formula? Why are we converting? It's like bumping around in the dark. You have no idea what you're doing or why you're doing it, so you don't remember. We're going to see actually why where that conversion formula comes from and why we convert that way, and that's going to allow us to remember it. And understand, and never actually have to use the formula again. Let's keep this in purple. If you want to convert between degrees and radians, you're just going to be able to think back and maybe draw a little picture, if it helps you. Think back to what is a radian, and that's going to allow you to figure out for yourself what the conversion is, how to convert. You're not actually going to have to remember the formula, and this is the way to do it. This is the way to do everything in trig and math. Be able to derive the formula for yourself, understand where it comes from and why it works, and then you'll never have to memorize anything, with a few very rare exceptions. But generally, you'll never have to memorize anything. Okay, so I know that there are 360 degrees in the circle, but how many? So this is 360. Actually, let me move this down here because it's going to be distracting if we bring this stuff up there. Okay. So here we are down by ourselves. 360 degrees are in the circle. How many radians are in the circle, though? Well, the number of radians, we get a radian by pasting a radius into, let me highlight this a little bit so that it's more visible, by pasting a radius into the outside of the circle, whatever the radius is, and this is a bit less than a radius. There, it's r. So in order to figure out how many radians there are, we think, well, every time I paste a radius into the outside of the circle, I get a radian of angle. So the number of radians and of angle in the circle is going to be the same as the number of times that I can fit a radius into the circumference of the circle. Right, so that is up here again. Right, what we were doing, we were going in steps of 1 radius all the way along the circle and seeing how many of these we could put in. Every time you do that, if you connect these points to the center of the circle, like up here, right? If that was folded back up again, that would give you one radius or 1 radian of angle, right? That radius that you can paste into the outside of the circle. So if I want to figure out how many radians there are, Well, I have to think, how many times can I paste the radius into the circumference of the circle? Well, the circumference of the circle, hopefully everyone knows, is 2 times pi times the radius. This is actually the definition of pi, the number pi, right? What is pi? Pi is the circumference divided by the diameter, which is the circumference divided by 2 times the radius, right? That's what pi is. That's where it comes from. And pi is a really cool, really interesting number. Take a look at the videos on that if you're curious. But the point is that we know in terms of the radius, we know exactly in terms of the radius, right, what the circumference is. So how many times, right, if I divide the circumference by the radius, and that's when I want to figure out how many times the radius goes into the circumference, right? If I want to figure out how many times like 2 goes into 6, I'll do 6 over 2, and I get 3, right? 3 2's go into 6. If the circumference was 6, I could paste arc lengths of 2, so strings or whatever of length 2 into it 3 times. And so because people have a little bit of trouble with this, you can think about it that way, right? These are just real numbers, pi, the radius, whatever it is. If I want to figure out how many radii can go into the circumference, well, I divide the circumference by the radius. And again, every time I can paste the radius into the outside of the circle, that gives me a radian of angle. So this leaves me with, well, I mean, the c over r is 2 pi r over r, the r's cancel, and I end up with 2 pi. And that is the answer to my question, that there are 2 pi radians of angle in a circle. And now it's really easy to convert, right? I know that there are 360 degrees, and let me actually, let me write this as 360, let me write this, DEG for degrees, I think is better than D and then R, because R will represent the radius. 360 degrees are the same as 2 pi radians. 2 pi radians are 360 degrees. So if I want to know what 1 degree is, well, first of all, what is 1 radian in terms of degrees? 1 radian is equal to, well, I'm going to divide both sides by 2 pi. 2 pi. And then the 2 pi's cancel to give me just the 1 radian, and it's going to be equal to 360 over 2 pi, or 180 over pi degrees, right? That is how many degrees are in a radian. There are 180 divided by pi degrees in a radian. What about the other way? If I want to figure out what is 1 degree in terms of radians, well, again, I use this relationship. 360, which makes sense because I know where it comes from, right? It actually makes logical sense because from what the circumference of a circle is and from what the definition of a radian is. If I actually take the time to understand these things, it's really easy to convert because I actually understand the relationship. Shockingly enough, when you actually understand it, it's easier than if you try to memorize things. So 360 degrees is 2 pi radians. That means that 1 degree, one that's supposed to be 1, I swear. 1 degree is 2 pi divided by 360 radians, right? Which is pi over, after I cancel the 2 and the 360, right, I end up with pi over 180 radians. So now it's super easy to convert it. And again, they typically skip all of this, and then it's like, okay, you multiply by 180 over pi or by pi over 180, and then people have trouble remembering this, and it doesn't click. Right? But if we think about it this way instead, in terms of the actual relationship, this definitional relationship here, or foundational, I'm not sure about definitional. Suppose now I want to find out what is 71 degrees in terms of radians. Well, I already found out that 1 degree, right? 1 degree is pi over 180 radians. So 71 degrees is equal to 71 times pi over 180 radians, whatever that is. I can whip out a calculator and calculate that, no problem. What if I want to know what is 2 radians in terms of degrees? Well, remember, I know that 1 radian from up here, 1 radian is 180 over pi degrees, which means that 2 radians, actually let's make it more interesting than 2. Let's make it like 2.5, say, 2.5. Seems a bit scarier. 2.5 radians. Well, 2.5 radians is 2.5 times 180 over pi degrees, whatever that is. And again, I can bust out a calculator for that. So that's how we convert, and that's it. Literally, that's it. And so hopefully this makes sense. Before we go, I just want to hammer this home one more time. I know I'm belaboring the point, but because this is Introduction to Radian Measure, and which is kind of the beginning of trig, and this is very important in trig and in math in general. I really just want to emphasize, and hopefully you'll believe me more after watching this video and seeing, now you actually understand what's going on, because we took the time to go through the details. That the way to succeed at math, the way to do well at math, the way to actually understand it, so you're not confused and stressed, so that it actually makes sense, is to take the time to understand these things, right? Make sure that it clicks. Make sure that you get answers to your questions. Make sure that you actually understand things on a deep level, that it all clicks and all makes sense, right? If it doesn't, don't move on to the next thing. Don't just memorize something and keep going, right? That is the higher up in math you go, that's just a recipe for disaster. You will really regret that if you don't get into the habit as soon as possible of cultivating this deep understanding, really taking the time to understand things, not just trying to memorize them and learn some trick or something and move on. This is the way you succeed. This is the way you get the top marks, and it's also much less stressful. People they don't want to do the work, right? They think, do I really have to do all this stuff? Do I have to spend the time and the energy? And the answer is yes, you do. But also that it's a lot less time and energy. Learning something once, as opposed to trying to memorize it, right, is much easier. If you actually take an interest in it and try to learn it and understand it, well, then you don't have to memorize it anymore, right? You can figure it out for yourself. You can remember on a test. Because the number of things you have to memorize, it just grows and grows and grows and grows. So if you get to the second half of first year calculus or beyond, if you've been trying to memorize stuff, it's going to be 20, 30, 40. They just proliferates out of control, the number of things that you're going to have to memorize. And if you don't have a way of remembering them, if you don't understand them, you don't have a logical way of keeping it in your mind, it just becomes impossible. It's like remembering random numbers. How easy is it to remember eight random numbers that I give you? Well, if I tell you it's someone's birthday, then you know the year and the month and the day. It's a lot easier to remember that than just random numbers in an order. And that's kind of not maybe the best analogy, but I think you get the idea. And I will quit blathering and let you guys go and see you in the next video.